Why can't RootCause do this and Gemini can't? Like, what does RootCause has in its engine to work and Gemini can't?
So root cause is an engine that uses statistics, but powered by AI in the sense that AI helps it use the statistics that we calculate to converge to a viable graph that explains causality. But it's all based on statistical definitions of what causality is. Imagine, like we saw with the Gemini example, it said do A/B tests, but honestly, you can actually identify A/B tests within the data that have already been done accidentally. Like these specific customers were exposed to these specific environments and this happened to them. These specific customers were exposed to these environments and this happened to them. You just take all of that and then you can isolate a lot of these cases, control for the groups that had this thing happen to them, had this thing not happen to them, control for all the other variables that could be influencing a specific outcome and just check for one outcome. And if that outcome is still explainable through one variable, then you can say that that's most likely the cause of the issue. And then there's the other side of the coin is, what if you don't have all the data? Correlations will not tell you if you don't have all the data. You need to start looking at things like what's the gap between explained and unexplained outcomes based on the variables and the data that you have. When you don't have that, it's called a latent confounder in the causal world. And we need to be able to understand that these do exist, and it's fine if they do exist, because a system like this will expose it if it doesn't exist. A machine learning model won't necessarily expose it because the machine learning model will be really good at overfitting on the existing data to minimize the error. And there's a lot of work that goes into machine learning to ensure that you don't overfit on the small sample you have. These kind of models are less likely to do that because they're structural models, there's guardrails in place for it, and you're not feeding in a bunch of data and you're trying to look at patterns that don't actually exist, and they only exist within the sample. You're only looking at patterns that are statistically assured that this is a likely causal relationship between one variable and another. So there's a whole raft of reasons, and all of this is wrapped up in an explainable package. So you can see the actual process, the flow between how the customer engages with your business and then the things they subscribe to and how that influences, if they subscribe to one thing, it influences their decision to subscribe to something else. And that influences the amount that they pay, influences what type of payment method they use. Like, if you're charging someone $2,000 a month, they wouldn't pay with cash. They're more likely to pay with card. If you're charging someone less, then they might want to use a different payment method. There's a lot of different reasoning behind that. And maybe that influences churn, because I'm sure you've seen a lot of companies now, they prefer paperless billing. And why do they prefer paperless billing? Because these land in your email. Who checks their email all the time? These emails go unnoticed. So sometimes you forget that you signed up to something, and often you just keep paying for it. It's a small amount. It maintains their churn metrics and their revenue metrics, but you don't notice it until they send you an email, and then you do notice it. Wow. So there's a lot of these factors that are actually well explained in this graph that Gemini just simply wouldn't be able to find. And then with our domain knowledge, as someone who's worked in this industry, hypothetically, if I haven't worked in telecoms, but if I did, I would then start to relate it to different tactics that we're using and why this is the case. But I would have evidence to support the things I'm about to present to a board, because I'm just going to get laughed out of the room if I tell them, just give everyone free tech support, because they'll start telling me, what's the ROI on it? Okay, we're going to give everyone free tech support. This is the cost of giving everyone free tech support. How many people will this impact and will turn them from high-risk customers to low-risk customers? And then what's the ROI on that? If they're low-risk customers now and they're not going to churn, then how much money do we actually, what's our revenue retention in comparison to how much we spend retaining the revenue? So all of these things, a simulation engine will be able to answer. Gemini would have to write some code, hopefully calculate the right things, and you wouldn't be able to get the evidence, except it would just be, an argument, as everything always is in these kind of situations. They'll go back and forth in an organization until everyone agrees on something to do, and no one's in trouble if it goes wrong. Bit of a charade, but that's why root cause is helpful for enterprises, and it allows them to make decisions fast, explainable, and more reliable.
I think of it as simply a way of structurally implementing statistics, not a neural net, at scale. And it allows me, as somebody who doesn't have a PhD, to get insights that would normally require a team of PhDs.
Neural networks are very useful. They're incredible things, but when you start throwing them at data problems and you don't understand the implications of things like overfitting and how to battle overfitting and how to look at things like distribution of classes, like if you build a machine learning model to predict churn, and churn is, they're only 5% in your company, and then the model predicts no, then you've got a 95% accurate model. And that looks great on paper. You can go to your board and say, my model's 95% accurate predicting churn. But does that counter for weighted classes? Like, does it weight the class accuracy or do anything that you should be doing? Was the rigor in the approach? These are all problems that I think as machine learning's become more mainstream, the importance of addressing these things has become less and less prevalent. And I think to some extent that in a large degree, it's been gamified, which is good because, as a machine learning enthusiast, I want more people to use machine learning. But when it starts getting translated in commercial environments, it causes problems. And that's why AI adoption keeps getting weaker and weaker over time, because people are rushing to implement the exciting technology without understanding how to govern the exciting technology and understand the limitations of exciting technology.